The next part of the lesson then is going to talk about what we call angle of elevation and angle of depression. Okay, gosh, got into the sun there for a second. It's a beautiful day. I don't want to be in here doing this. I want to be outside, but whatever. Maybe go for a run. Maybe I'll do that over lunch hour. Anyway, so angle of elevation and angle of depression. So angle of elevation and angle of depression are really talking about these right triangle concepts where you've got an angle that's elevating kind of as you look up to something in the sky, or it's depressing as you look down because you're depressed and you think you need to look down at the ground because that makes you feel better. Angle of elevation and angle of depression. So we're talking about angle of elevation. What we're talking about when we're talking about angle of elevation is we're talking about the angle. So there's going to be a right angle here. So let's say we've got kind of a plane. This is my plane. That's my plane. Say you're looking at a plane up in the sky, and this is you standing down here, or me standing down there. And I'm looking up at this plane. So I'm looking parallel to the ground up. That is what's called, this angle right here is what's called the angle of elevation. And that angle of elevation is really, again, it's that angle that's created by going parallel to the ground and kind of up to a specific location. And you can measure some different things. And because we have a right triangle, then with that angle of elevation, if I know what that angle of elevation is, there's this little device that, you could look through. What you do is you can put a straw up and you can look up at an object and you put a protractor down and you could find a measure of the angle, or they've got other devices that do it too. Or in your case, they'll just tell you what the angle of elevation is. You can look up at that object and come down at it, and you could find that angle of elevation. And then if you know one other thing, you can find, the height of it. You could find the length of the string. You could do a bunch of different things with this when we're talking about angle of elevation. So an example of something that would be like an angle of elevation problem, and I'll use this plane kind of as an example, is let's say that we're standing, we're looking up at this plane, and I've got this little device, or let's say it's a drone. Okay, so you've got this drone, and the rules for the drone say that you can't fly above 100 feet, 300 feet, I don't remember what the height is, or whatever. There's this certain height that you're restricted to. But let's say that you take your drone out and you're flying the drone across the field, and you're sitting at a height of 100 feet. So the height of the drone from the ground, let's say, is 100 feet. And you've got a little device that measures the angle of elevation. And the angle of elevation is, when you're looking at it, let's say that angle of elevation that you're looking at is 34 degrees. Well, let's say the batteries just die and your drone just dies and your drone goes whoosh to the ground and it just drops straight down. And you have to calculate how far you have to run to go get that drone, or walk, whatever. So you want to know what distance you are from that drone. Does it probably tell you on your little screen? Probably, but what's the fun of that? We can use sine, cosine, and tangent to find missing sides of triangles, just like we did here just a few minutes ago in the last little section of the video. To find this, if we identify the sides according to the angle that we're given, 100 is the opposite. This is the adjacent. Opposite and adjacent is tangent. So tangent of a measure of our angle, which is 34, that's going to equal the length of the opposite, 100, over the adjacent x. Okay, so remember when we did this in the last lesson, if that x was on the bottom, we multiplied both sides by x. So that was x tangent of 34 equals 100. Divide both sides by the tangent of 34, and you're going to find out how far you are from your object. Tan, clear, tan. Oops, I gotta go 100 divided by tangent 34. So I am 148.3 feet from that object that fell straight down out of the sky to the ground. And that, again, that's called the angle of elevation. Okay? Let's look at another angle of elevation problem. Okay, so let's say that now we're flying a kite. Okay, so here's my drawing of a kite. And I'm standing here, flying my kite. And now this time, I've got little markers on my string because I want to know how much string I've let out. So every 10 feet, I've got a mark on my string of my kite. And let's say I know I've let out 400 feet of string. I measure my angle of elevation, and my angle of elevation is 48 degrees. I want to know how high that kite is flying, given that I am holding my arm 4 feet off the ground. Okay. So the first thing we're going to do is we're going to solve the triangle, and then we got to think about, okay, my hand is 4 feet above the ground, so what do I have to do with that 4 feet kind of at the end? I don't need to use it at first, but I'm going to need to use that at the end. So we're going to find the value of x here. So opposite over hypotenuse, so this is sine. So we're going to go the sine of our angle, 48, is equal to the length of the opposite x over 400. The number's on the bottom. So we're going to go 400 times the sine of 48, and that's going to equal our x value. That's 297-ish feet. So we'll just say that's 297 is equal to x. But the question said, what's the height of it? So to find the overall height of this now, I do need to add that 4 feet on there because my hand is 4 feet above the ground. So my kite is flying at approximately 301 feet. And it's using that elevation. Okay. Angle of elevation. So that's the angle of the elevation. The other one we had was angle of depression. So when we're talking about angle of depression, this one gets people a lot. The angle of depression is the angle that is created by looking parallel to the ground down to an object. Okay, parallel to the ground down to an object. So if my plane is right here, the angle of depression is parallel to the ground down to the object. So that right there is my angle of depression. Okay. And I'm standing down here. This right here is the angle of depression. And the angle of depression confuses people a lot because you can imagine a lot of people say that's the angle of depression. That's not the angle of depression. The angle of depression is this angle right here. It's parallel to the ground down to your object. Okay? And that's how this always has to be done. Now understand that the angle of depression, and if you think about where's the angle of elevation on this object, remember the angle of elevation and the angle of depression. Angle of elevation is parallel to the ground up. The angle of elevation is actually right here. Okay, and the other thing that we know is that the angle of elevation and the angle of depression, those are going to be congruent to each other because you think about the angle that I'm parallel to the ground up, that's going to be the same as the angle parallel to the ground down. So the angle of elevation and angle of depression are actually congruent to each other. Okay? So let's say that we've got this plane here again sitting, and how we're going to use the angle of depression. Say we've got this plane here sitting down there, and let's say that this plane is going to land on me, okay, and it's 230 miles. from me right now. And I know it's 230 miles from where it needs to land. Okay. Let's say that it is going to fly at, let's say the angle of depression is 32 degrees. And I want to know how high this plane is in the sky. Okay. So we've got a right triangle right here. So x is the opposite, 230 is the adjacent. So that's tangent of 32 is equal to the length of the opposite over the adjacent. The number's on the bottom. So I'm going to go 230 times the tangent of 32. So it's 143 miles in the sky. Not realistic at all, but whatever. It's way up there. Probably don't want to fly at a 32-degree angle down and land. It's not going to go well for you, but whatever. But that's what the angle of depression is. And you got to be really careful with that angle of depression. And make sure you understand exactly where that is going to be. Okay, let's look at another example of angle of depression. Okay, so let's say we've got the sun up here. And we've got a building that's creating a shadow. So we've got this little bit of a shadow going on. And we've got a guy standing up on top of the building here. That's us standing on top of the building. And there's a boat out here in the distance. My nice boat. There's a boat sitting out there in the distance. And let's say that this time I know that my height of this building is 60 feet. And I know that I am 150 feet from that boat. This time we want to find the angle of depression. So we want to find the angle of depression. So right now the angle of depression is not drawn in there. Okay? In order to draw the angle of depression in there, I got to extend this and down because my angle of depression is right there. And now I got to transfer my numbers. So this was 150, so that's going to make this 150 because it's a parallelogram. This is 60, this is 60 degrees. So now I asked you for the angle of depression this time. So you want the angle. So since we have to find the angle, we label our sides first. Opposite, opposite, and adjacent. Opposite and adjacent is tangent, but because I have to find the measure of the angle, remember we do tan -1 is the length of the opposite over the adjacent. So second tangent, 60 divided by 150. And you get 22 degrees is that angle of depression. So you have to be a little bit careful when you're doing these angle of elevation, angle of depression problems. You're going to be asked to draw things a little bit today. Sometimes you're going to have to find angles. Sometimes you're going to have to find the length of missing sides. Make sure you do those things when you're doing this second piece of the lesson. And as always, if you have questions, make sure you ask during the next class or send me an email and I'll happily answer it. Enjoy the day, everybody. We will see you next time.